Alright, so 2.1, so we're starting chapter 2. 2.1 is measures of growth. And 2.1 is specifically looking at changes. Alright, we're looking at the exact change, the percent change, and then the speed, how fast it's changing. And they're all different changes, and they describe it in different ways. Alright, so we're going to be looking at functions. And a function is a relationship between two variables, all right, where one variable depends on the other variable. And typically time is the independent variable because it's how things change, right? One variable is affected by the other variable. So like I said, time typically is the independent variable because things typically change with respect to time, right? Populations grow over time. Money changes over time, right? Your cost changes, profit changes over time. It can change with respect to other things too, but independent is what's causing the change, right? The independent variable is what goes into the function and affects what comes out of the function, right? Independent goes in, so independent typically we say x is the independent and y is the dependent, all right? So again, when we write a function, it's typically y equals f of x. X is the independent, y is the dependent. What I put in the function for x is what I can do. I can put in the x and it changes how y comes out. All right, the absolute change in a function is the change in the function output values. And typically we take, if we're going from xa to xb, from a to b, the change is we take the second value function, plug it in, f of b, and subtract the starting value, f of a. And that's the absolute change. That's how much the function changes. The value of the function changes from a to b. So if a is the starting time times 0, b is 2 years later, and suppose f is my population, will be the population 2 years later minus the population right now, and then you subtract that, and that tells you how much the population changed. Did the population go up or did the population go down? A positive number would mean it goes up, a negative number means it goes down, and this would be exactly how much that change would be. Alright, so absolute change. Right, difference in our function values. The percent change, all right, or relative change in a function is the percent increase, or it could also be a decrease. It says increase, but it can also be a decrease in the function from one value of the independent value to another. All right, so we go from one function's independent value to another. So there's a starting value, a, f of a, and then where we're changing to, b. Alright, so the percent change is the change in the function, and it's that absolute change that's up here above. So this would be the change in my function from point A to point B. And then you divide by your starting value. Alright, that's what this is. This would be the starting value. Where you started, the number you started at. Alright, and then again you multiply by your 100% to make it a percent change. And that's to be how much the function grew as a percent of your starting value, all right, whatever that starting value is. So if your population was at 10,000 and it grew by 2%, all right, that means it would grow by 2,000, all right, so it should be at 2,000, it should be at 12,000 at that point, all right, and so that's the description in the percent change. All right, so actual change or exact change, percent change, and then the last change we're going to look at in this section is what's called average rate of change. This is the one, if you've taken an algebra class, this is the one they talk about a lot in algebra. Average rate of change of a function is how a function changes with respect to the independent variable. So it's the change in the function over the change in the independent variable. So a lot of times we'll say it's the change in y divided by the change in x, which is a slope. Alright, it's the change in the function. So if I have a table of values, suppose this would be the function's values, whatever we're talking about. This would be the independent. And again, a lot of times the independent's time. So this would be a, f of a, b, f of b, c, f of c. Alright, so suppose we want to know the change between a and b. That's the change we're looking at. And so the average rate of change would be the change in my function. So I usually would take the bigger value, the value later on, the future value, f of b, subtract f of a, so that's the change in the function. And we divide it by the change in the independent. And again, you want to be consistent, so it would be b minus a. Use the same values that you started with. This would be the change. In algebra, this would be the change in y over the change in x. All right, and again, that's a slope, if you remember that from algebra, change in my function. What this does, the average rate of change is actually very fun. Whenever we talk about changes and things, a lot of times it's average rate of change. It's how fast the speed, if it's a big number, or slow, if it's a small number, a function is either increasing if it's positive or decreasing if it's negative over, whatever the input variable is, the independent variable is. Again, a lot of times it's time. Doesn't have to be time, but a lot of times it is time. All right, so it's the rate. All right, so if it's years, a lot of times things are years. So if it came out 100, and it's over years, so it would change by 100 units per year. So suppose it's people. It's a rate of change of my population. So my population grew by, that's how, 100 people per year. So that's the speed. That's how fast the population's growing. So average rate of change. So again, those are the three changes we're going to look at. So we're going to look at an example that we're going to walk through all three. All right, so suppose we have a salary, right, of an employee is noted below. So again, we've got the year and their salary over that year. So time is always the independent. What year you're in affects how much salary. Again, because salary is how long you've worked. Salary is also based on inflation rates and other things like that. And so depending on what year you pick, the salary changes. So the salary is dependent on the year. All right, 1990, there's a certain employee average for their salary, and then in 2010 it's different. And typically it goes up because, again, inflation rates and things like that, salaries tend to go up over the years. All right, find the absolute change in the salary from 1990 to 90. So this would be the start. This would be the future value. And so we want to start in 1990. We want to find the absolute change. We want to find the change in the salary from 1990 to 95. And so, again, we take the future value and subtract the starting value. So you're going to take the 63,500 minus the 50,000, and that will be how much the salary changed from 1990 to 1995. All right, so the salary change, when you do that change, it comes out 13,005. And it was an increase. It came out positive. So the salary increased by that much over those 5 years, right? So from 1990 to 1995, the salary rose by 13,500. All right, find the percent change over those same years. So again, how much did it grow in a percentage? We knew exactly how much it grew, and we want to know, and the percentage is based on your starting year. How much more of the money did we make in 1995 based on the 1990 salary? So the percent change, remember, is the change in the function, the absolute change, divided by where we start with, right? It's the change in the, so it's the change in the function divided by your starting value times 1,000, or sorry, 100%. All right, so if we did this, we do know the change here, but I'm going to write it all out. Right, so it would be again, from 1999 to 5, so the change would be that 63,500 minus our 50,000, and what we're going to divide by is we divide by the starting time, so that we're started at 50,000, and so that, because it's a percent change from where I started, right? How much did my value change from the 50,000 I started at? And then we multiply by our 100% to put it into percent. And so again, it was our 13,500 divided by our 50,000 times 100%, and it comes out 27. I'm rounding to the whole percent. And so the salary grew by 27%. All right. Compared to the 1990, it's compared to the starting time. So the 27%, it's 27% higher than the 50,000. So it'd be 27% of the 50,000 is what we add. If you actually took 27% of 50,000, it would come out to that 13,500. All right, now find the average rate of change over those years. So remember, average rate of, so there's absolute change, the exact change in the function, percent change, right? So it's the change in the percentage from our starting year. And then the average rate of change is the change in my function over the change in time. So there's two changes in the average rate. It would be the change in salary over the change in time, right? It's the change in the function over the change in the independent's time. So it's how fast is the salary changing over time. All right, well, the change, and again, I'm going to write it out so you can see it. It'll be the same change that we had up here in part A, but I'm going to write it out. So it's the change in the function, so it'd be the 63,500 minus our 50,000 over the time. The time should match, so the 63,500 went with 1995. The 50,000 went with 1950. And so it's a 5 years. Over that 5 years, how fast was the salary changing? So up top, the exact change was at 13,500. We divided out over the 5 years is what we're doing. We're taking the 5 years and dividing it out. And so it comes out to be, I have to write it down, so I have to type it out. So it's our 13,500 divided by 5, which comes out to be 27,000. All right, so it's growing, increases at a speed, at a rate, and an average rate. Again, rate would be how fast, the speed, of 27,000 per year. And basically, you can kind of check your answer that you did it right. If you took the 50,000 and added 5 of these to it, you would get to the 63,500, because every year you get to add 2,700 to your salary. So 5 times you added 27,000 to your salary. So if you start at 50,000, you add 5 of those, you get to 63. And actually, we're going to be doing that later on. We'll be using the rate of change to do that. It's a specific method on how to figure out and guess what the future values are going to be. All right, so every year they gained on average 2,700, not 1,000, 2,700. All right, so we're going to do the same thing. Now we're just going to pick different years. So we're going to do the same thing. We're going to find absolute change, percentage change, and average rate. But this time we're going to look between 2000 and 2005. So I got to go get my 2000 and 2005 years. So this is the years I'm looking at. So this is where we start. 2000. This is our future value. All right, so our future value is 75,100. So when we find the absolute change, you take the future value, 75,100, and subtract the 22. So subtract 65,900. And so that comes out to be 9,200 is the increase over those 5 years. Again, we did a different value. So depending on which 5 years I'm looking at, I got a different value, right? It rose by 13,500 between 1990. So it had a bigger change between 1990 and 1995 than it did between 2000 and 2005. There was a smaller change. They both still grew, but it was a smaller growth between the smaller increase from 2000 to 2005. All right, now let's find the percent change. So it should be smaller than 27%, right? Based on just the fact that I know this is a smaller increase over 5 years. All right, so percent change. Remember, percent change is the change in my function over the starting value. This is the starting value, the 65,900. And so again, I'm going to write it out. So it's the change in my function divided by, so it's the change from my starting year. My starting year is 2000, so we divide by the 65,900 and then multiply by our 100%. So again, it's going to be that same value, so it's going to be the 9,200 divided by our 65,900 and then multiply by our percent, put it in a percent. I know it's going to come out less than 27%, and it does. It comes out 13 some decimal, I'm going to round to 14%. All right, so from 2000 to 2005, it is a slower percent change, right? It grew by 14% from the 2000 salary. All right, so 14% of the so we get to add 14% of the 2000 salary. All right, that's what we did. That's how much it grew. So it was much less. It was, and from 95 to 90, it grew by 27%. From 2000 to 2005, it only grew by 14%. So it was smaller. So the average rate of change should also be smaller, right? It should be smaller over these years. All right, so again, same thing. Average rate of change is the change in my function. So in this case would be the change in the salary over the change in the independent, which is time. All right, so the change in the salary, which would be the 75100 minus the 65900, the change from 2005 to 2000. Remember, it goes 2005 minus 2000. Biggest thing here, you can actually switch the subtraction. Just make sure you're consistent. The first two numbers should be the pairs together, right? 2005 was the salary, 75,000. In 2000, the salary was the 65,000. All right, so the biggest thing is make sure they're paired together. All right, so the change was 9,200 over those 5 years, and so the average rate, you divide that out, and so that comes out to be 1840, so it was much smaller. Our previous rate of growth between 95 and 90 was 2,700. This is almost 1,000 less, all right, 1,840, and so it still grows. It grew at a rate, on average, of 1,840 per year. All right, so every year, that's how much more we got to add to our salary. So again, to kind of check the answer, if I took the 65,900 and I added 5 of these, because that's how much I get to add every year, it should add up to the 75,100. And it does. If you check it, it does. All right, so now we're just going to practice finding these. I'm going to just do the next example in the next video. So I'm going to stop this video here, and I'm going to do the next example in the next video.